question says find the volume of the solid obtained by rotating the region bounded by given curves. Either use a disk method, or if you have two curves, you can use washer method. Very good. So let us visualize this. What's going on here? Here you have y squared equals to x cubed. And then you have x equals to 4. Then you have y equals to 0, and you're rotating about x-axis. So let's take a look at visualization here. What does this guy represent? My x-axis, my y-axis. So x equals to 4. You get a vertical line here. Then you have y equal to 0, which is your x-axis basically. So this is x equals to 4. Then y equal to 0. And you have y equals to, if you want to rewrite this guy, this is y equals to square root of x cubed. Okay, the graphing is not that difficult. If I plug in 1 here, my y becomes 1. So add 1, you have 1. If I plug in 4 here, y equals to square root of 4 to the third. Well, you can simplify this as well, or you could write this guy as x times square root of x, or your y becomes 4 times square root of 4, or 8. So at 4, it should be go up here. So we expect the graph to behave like this, just by point plotting, nothing really complicated. Okay, my graph is not very precise, but you get the general idea of what's going on here. You get y equals to x times square root of x, or y equals to square root of x cubed. Very good. So what are we trying to do? We're trying to rotate this about x-axis. Okay. So you take this guy and start rotating this. By rotation, you end up with a 3D object. Well, let me use the same color. Later on, we want to use the cross section and see how the cross section work. Okay. So if you think about the cross section, the cross section, a typical cross section is located here, am I right? This is just a disk. And if you think about your radius is located on x square root of x, or the square root of x cubed, right? This is your cross section here. Well, we know that the area is equal to pi r squared, or in this case, pi times x times square root of x to the second, or pi times the square root of x cubed. Just correct this before I move to the next step. Or pi times square root of x cubed to the second, which is x cubed. Perfect. So I can write this volume as the definite integral a to b of pi of r squared, which in this case is just r squared, or r of x dx, which is the integral, the definite integral, 0 to 4 of pi, and r squared is equal to x cubed, which we just saw, dx. So this integral in turns is 0 to 4 Let us just calculate the integral because this is super easy integral. This becomes pi over 4 x to the 4th, and x ranges between 0 to 4. Again, 0 doesn't change anything here. We just need to plug in 4. We get pi over 4 times 4 to power 4. If you cancel out one of the 4's, and 4 times 4 times 4 is 64 times pi. Very good. Next question says, now suppose you have x plus y equals to 1, and x is equal to 0, and y is equal to 0, and then you start rotating this about x-axis. So these are the information that we have. X is 0, y is 0, and the rotation is also about x-axis. Okay, let us visualize this. What are we dealing with? What is this object? So the line y equals to 1 minus x. If x is equal to 1, it hits x-axis. If y is equal to 1, then your x is equal to 0. So this is the visualization of this decreasing line, right? And then x equal to 0, y equal to 0. So you're basically looking at this triangular object, right? You try to rotate this object about x-axis. So the rotation about x-axis is similar to, okay, we're taking this guy and start rotating this about x-axis. So expect it to be this 3D object like this. Very good. So now what is a cross section? The cross section is basically here. It's just a typical cross section that I take for you. The cross section starts at this point, which is 0, then start increasing, and then it takes on the maximum form this way. This is your cross section. So this cross section, you can take a look at this cross section here, which is a circular object, or in this case, it's a disk. And then when you're finding the radius of this disk, it is located on the curve, but the curve here is just a line. So it is located on y equals to 1 minus x. This is your radius, or r of x. So the area of the disk is pi r squared, which is pi times 1 minus x to the second power. Very good. So let us go back to volume. The volume is equal to the definite integral. Take a look. It hit x-axis at 1, and the starting value is at the origin 0. So 0 to 1, and pi r squared, which is 1 minus x to the second power dx. Here you have different options calculating this integral. You might say, hey, I want to use u sub. Why not? You can use u sub. Or you can write this in expanded form. So the volume can also be written as 0 to 1 pi 1 minus 2x plus x squared dx. Or you can use u sub. You can say that, hey, my u is equal to 1 minus x, then calculate du, which is negative dx, and continue. So either this or this. So the volume is equal to pi, and the integral of 1 is x. The integral of negative 2x is x squared, and the integral of x squared is x cubed divided by 3. X ranges between 0 to 1. Plug in 0 doesn't help because everything disappears, so just plug in 1. You get pi 1 minus 1 plus a third. So as you can see, these two terms, they cancel out each other, and you're left with pi over 3 as the volume of this object